Welcome my friends. In this video we're gonna talk about the following integral, tangent to the fourth x dx. So I wrote these some things that we're gonna be using. So in previous videos I used identity substitution. So we're gonna use those type of methods. We're gonna use secant square, the identity secant square x minus tangent square x equals 1. We're also gonna know the fact that the antiderivative of secant square is just tangent x, and vice versa, the derivative of tangent x is going to be equal to secant square x. If we solve secant square x as follows, so secant square will be secant 1 minus tangent square x, and then tangent square x is going to be equal to secant square x, and then that's gonna be equal to minus 1. Okay, this fact is very important because what we're gonna do when you have even powers for tangent and you have tangent by itself, what you're gonna do is you're gonna leave a tangent square by itself at the beginning, and then the rest here you're gonna change it to secants. So how you're gonna change it to secant? Using the identity, but we solve it. So tangent square, because right now we have here we have tangent square x, but instead of tangent square x we're gonna substitute it for secant. So this becomes secant square x minus 1. Then what we're gonna do is we're going to distribute this tangent. So we're gonna get secant square x tangent square x, and then we're gonna do so let's start separating. So this becomes here, and this becomes minus tangent square x dx. So that's the second step. Now this integral we can solve it, and then this integral here we're gonna have to so what I suggest is you take one integral, solve it, and then you do the other one, and then combine the results. What I would do is this one first, because this one you can use substitution. Then we'll take care of this one. Use substitution, you let tangent x equals u. So what do you think du is gonna be? Du is gonna be this, and remember here we have dx. So dx times secant square x is gonna be du. It happens to be. Okay. So the derivative of u is gonna be secant square x dx. So knowing that fact, we can replace this integral as follows. It's going to become u square du, and then minus the integral. But what I'm going to do to save some time is that we're going to convert this again to secants. Okay, so we're going to do, so this becomes secant square x minus 1 dx. Okay, so now back to this one, u square. You're gonna use the power rule, so it's gonna be u cubed over 3, and then we're gonna do minus. Okay, what's the derivative of antiderivative of secant? That's gonna be equal to minus tangent x, and then minus times a minus becomes positive. So, but I'm gonna leave the minus here. So what's the antiderivative of minus 1? Is gonna be negative x, but negative x times negative becomes positive x. But because we have integrals here and we have we have indefinite integrals, we're gonna put plus c. All we're left is to plug in u. What is u? Remember, u was we let u equals to tangent x from here. So basically, So I don't like to put it here because I want you to see it clearly. So u cube over 3 becomes tangent cube x over 3 minus tangent x plus c. So that will be your final answer. Let's see the minus. I don't want to lose minus this time. Okay, so u squared, that's okay, minus tangent, then positive x plus c. Okay, so now it looks good. So this here becomes this by plugging in your u, which was tangent. U was tangent x. All I did is plug in tangent here, we get the answer. Alright, thank you very much, my friends. Don't forget to subscribe. You really help me a lot by supporting my channel. Thank you.